is a very important concept. Okay, I will also discuss the most optimal solution for this question, which is named as maximum path sum from any node. Now, what question says is that given a binary tree, the task is to find the maximum path sum. Maximum path sum. Path sum the path may start and at any and end at any node in the tree. Means we can start at any node and can also end at any other node. So suppose for this example, what is the path which is having the maximum sum? It is like this: 20, then 2, then 10, and yeah, that's all. Because if we proceed to the minus 25, then obviously our sum would get decreased. Is the answer. And here you can see the path can start from anywhere and can also end at anywhere. For this example, 2 plus 10 plus 5 would be our answer, that is 17. So now, uh, how to proceed with the solution? Also, you can see here that the number of nodes can be 1 to 10 to the power 3, and the data on node, it is mod 1 to 10 to the power 4. So it can be minus 10 to the power 4 also. So now, how we will solve this problem? So obviously, one of the brute force is that I will go to whenever the node at I am. Suppose if I have the maximum path sum in the left, and if I have maximum path sum in the right. Okay, so there can be two cases. Suppose I have these two quantities, left and right. Now suppose if this is a positive number, suppose if this is a positive number, obviously what would be the answer for this node? L plus root data plus r, let's name it D, root data. Okay, plus r. So but if it is a negative number, obviously we would not like to include this. Why? Because obviously it would decrease my answer. That's why I would take the maximum of L and R, and I will just proceed to the next node. Okay, so and in this way I will also keep a answer variable, and at each node I will take the maximum sum which can be obtained at each node. Means how I am proceeding with the solution is that I will go to every node and will see what can be the maximum sum in at this node if I am having the left subtree path and right sum path. Okay, so yeah, that's the brute force. So let's move on to the solution. I will keep a answer variable and initialize with int minimum. Okay, so now I will create a function answer, and also, okay, nothing more than that, int result is equals to, and one of the cache is here, one of the edge case can be here. Since we have not been allowed to take an empty path, means the path which will not be having any node, which means the path should have at least one node. So there can be one edge case. What it will, when all the data, when all the node data will be negative, then what will you tell? If we have been allowed to take the empty path also, then obviously our answer would be 0, because we would tell that we would not select any of the node, since all the node data are negative. So it's uh, it's more like that we would not take any node, and the path would be empty and our sum would be 0. Okay, but now since it is not so, so that's why this is the case, this is the edge case, so I will also consider that. Now I will take care of that edge case explicitly, but let's first of all create this void solve node star root int ampersand answer. Okay, now suppose if root is equals to null, then obviously I would have to return. Okay, else this should be, no, this should not be in. I will call the function which will bring me the left and the right sum path explicitly. Okay, so what I will do, int left sum path. Okay, and for calculating the sum path sum, one thing you should notice here, that suppose I go from 4, now it will return 4 to this node. Okay, and now after including this, it has become minus 21. So does it make sense to carry this minus 21 further? Obviously not, because if I carry this, so my answer will only get decreased. It will never increase because it will only decrease the path sum. So it's more optimal. So it's like cadence algorithm. So we will follow the cadence algorithm for calculating the path sum. So that's all about. So let's create this path sum function in path sum. I will pass the root star root. Now if root is equals to 1, then I would return 0. Okay, else I would first call left answer, just bring me the and int right answer is equals to path sum of root right. Okay, now what I will do, left answer plus equals to root data, which I have explained you. Means if I am at this node, suppose if I am at this node and 10 has asked me, uh, tell me, tell suppose if 10 has asked minus 25, means its right child, to bring the path sum. Okay, so now it will call further to 3 and 4, and here you can see 3 would be returned and here 4 would be returned. Okay, so that's why I have this write this function int left answer and right answer. Okay, and now one thing you should observe, that I would uh, do 3 minus 25. Obviously it is plus minus 25, but it will be minus 25 it becomes. So, and one other quantity would be 4 minus 25. Okay, so that's what I am doing, and right answer plus equals to root. Now I will apply the cadence algorithm. Left answer if left answer becomes less than 0, obviously it is optimal to pass only 0. Means I would not carry any negative numbers further. Okay, so it's better to uh, make it 0. If right answer is less than 0, if right answer is less than 0, obviously the right answer would become 0. So now I would return the maximum of left answer comma right answer. Okay, so I have created this function, so I will just call. Now I am at 10. Suppose I am at 10 and I call this to bring the call in its left and the right child to bring its path sum. Okay, so what will be the code? The code will be like this, and write sum path is equals to path sum root right. Okay, now since I have the left sum path and the right sum path, what I will do now, I am having three options. First option is just take the first option would be what, obviously the our answer can be either in the left. Suppose this is the node, so our answer can be in the left, either in the right, or we can make this including the left and right and the current node. Why I am saying so that, suppose it is minus, it is very big number, it is negative. So obviously if it is negative number, then I would take on either only the left, either on all the right, and all, not only that, I will take the maximum of both. Okay, so these are the two options, and then and the third option is that to include this node also. So that's why I will perform like this. In top option 1, there is no need of it, obviously. First I will obtain the answer for solve of root left comma answer. And option 2 is just bring me the answer for the right part. And third option would be what, I will include this left sum path plus right sum path plus root data. Okay, so now I will just return the maximum of these three. So yeah, this should work. And before this, what I have told you about the age case, I would also have to manage that. Mx is equals to, suppose int mean I have initialized it. Now whenever I go to a node, I will say mx is equals to max of mx root data. Why I am taking maximum? Suppose if the maximum itself is a negative number, so obviously the number, all the number except that number would be either less than equals to, so obviously that would also be negative. That's why. Now if I would first check if mx is less than 0, so obviously I would return mx, because if all the numbers are negative, so -2, -1, -3, suppose, so -1 would be our answer, because -1 is the greatest of all the negative number. So if that's not the case, then I will return the answer. Where I have made a mistake, 103. Sorry, it would be answer. So yeah, it is 32. Let's submit it. Although it will pass because the n is less than equal to 10 to the power 3, so n square will also pass. but obviously it is n square solution. You can see it is 10 to the power 3, so that's why it is being passed. And but you can see the interviewer might ask you to optimize is to big of n. Okay, so now one thing you should observe for getting the optimal solution, what you are doing extra, what you are doing extra step in this problem. Obviously I am explicitly calling this path sum, which is again taking big of n solution. That's which is making this code solution to big of n square. What if just I pass? What if just I obtain this left sum path and also this answer for the left from the left and the right part in a single call? If I am able to do so, then obviously I would bring the time complexity to big of 1. So let's just try to do that. So okay, now what I will do is that I will just modify my solve function. Instead of passing only a single answer, means what my pair indicate, let me first declare this pair int comma int. Okay, so the first number will indicate the answer of the subtree. What I mean is that here you are obtaining the answer named as OP1 and OP2 from the left and the right respectively. So that it is indicating, no. Suppose if I call for the left subtree, then this first will indicate the answer in the left part, and if I call for the right, then first will indicate the answer in the right part. And what is the second number indicating? Will return this path sum. This maximum path sum in the corresponding subtree. Okay, so I will do the same, but this time I am returning the pair of int comma int. Okay, so this all will remain same, but the writing of code will differ this time. Okay, the concept will remain the same. Now if root is equals to null, then obviously I would return 0 comma 0. Means the answer will all the answer in the left subtree will also be 0, and the answer in the right subtree will also be 0, and the second number will return this, and also the path sum will also be 0, as the tree is null in the left and the right. Okay, suppose I obtain the answer named as left answer, just bring me the answer from the left part. Okay, I will also dry run, so you will understood it. Okay, you will understand it. Right answer is equal to solve of root right and answer. So now I am having with the two things, means the answer in the corresponding subtree, answer in the corresponding subtree, and maximum sum path in the corresponding subtree. So now I will do the same which I have done previously in the brute force. Okay, so what I will do, I will first create an answer which is to be returned at this node. Okay, now answer dot first, answer dot first indicate what, the answer of the subtree. So corresponding this node, means considering this node, obviously this node will also be a subtree of its parent node. Obviously yes. So I am only considering this node, and the recursion will take care of all the other nodes. Okay. So now I will just consider this. So I had told you that to obtain the answer of the subtree, there will be three options. There will be three options. What are those options? Just remember previously we were calling this solve function for the left and the right subtree to bring the maximum sum, means maximum answer from the corresponding subtree. That's what and we were having three options. So here we will again of having three options. Left answer dot first means answer from the left subtree, int option 2. Right answer dot first, okay. And the third option would be what? Option 3 is equals to, means take the take the maximum sum path from the left and take the maximum sum path from the right, and also include this root node also, means also include the root data also. So left answer dot second plus right answer dot second plus root data. Now answer dot first would be, obviously our answer dot first would be maximum of option 1 comma maximum of option 2 comma option 3. Okay, and now we have to also make the answer from the second for the second part, and I will follow the same which I have done in the path sum function. Okay, what I have done that first call the path sum from the left answer, then path sum from the right answer, and I will include the root data to it, and if it is less than 0 then I will make it to 0, and similarly for the right answer, and will take the maximum. So I will just do the same. Okay, let's name this left path sum is equals to, what is this left answer dot second. Okay, in right path sum is equals to, what is this right answer dot second. Now I will include left path sum is plus equals to root data, right path sum plus equals to root data. Then suppose if left path sum is less than 0, then it would become 0. It's better to make it 0, because I would not like to carry the negative to the parent node. Okay, if right path sum is less than 0, then I would make right path sum is equals to 0. Now our answer dot second would be the maximum of left path sum comma right path sum. Okay, and finally I will return the answer. So let's first erase this. Oh, there is no need of it. And one thing I forgot. No, I have not forgotten. So now our answer would be stored at the second. So it will be second. So it will be second, and anywhere else? No. So our answer would be stored at, since it has returned pair, so our answer would be stored at first. Sorry, it will be first. Now if mx is less than 0, again I will check that condition. If all the node data are less than 0, obviously the answer would also be negative 1. So let's submit it. Where I have done mistake. Sorry, actually it was, there was no need of it. There was no need of it. The previous solution also there was no need of it. Since we are just passing the it was saying that you have already make integer type, so how can you make a pair of int comma int with the same name? That's why I have erased that. So yeah, it is giving the correct answer. Let's submit it. So it got accepted. So now you can say that it is big O of n solution. Why? Because at each node I will just call, I am just doing all the things in a single call. Whereas in the previous solution, what I was doing, that I was explicitly calling this to bring the path sum, from the left and the right child. That's why it was explicitly taking big O of n solution. And now already we have been running the function named as solve, so that's why it become big O of n square solution. And now this is the most optimal solution, which is big O of n, and space complexity would be obviously height of the tree, because we would not go beyond the height of the tree at each step. So in the stack there can't be more than height number of elements, so that's why it will be big O of height of the tree. So yeah, I have told you that I will dry run. So let's dry run over this case. Okay. Suppose I have made a call to first I have made a call over the root, which is 10. Now it will make a call to 2. Then it will make a call to 20. Okay. So just uh, just mark my word. Listen me carefully. Okay. So what does this 20 will return? This 20 will return 20 comma 20. Means it will say that till now the answer is 20. My answer is 20. This will indicate the answer, means the maximum path sum possible in this subtree, and this is the maximum path maximum path in its left subtree, in its right subtree, either in its left subtree or the right subtree. Okay. And similarly this will also return 1 comma 1. Now I am at node 2. I am at node 2. What I will say, for making the first answer, means what can be the maximum path sum, path sum at this node. So there will be three options to take the left answer dot first, means which is 20, and the right answer dot first, which is 1, and also to include this node. And third option would be to include this node to and to which, means if I am at 20, then I will say okay, just bring me the path sum in the right, in the left, and just bring me the path sum in the uh, right. Okay. So where I was storing that quantity, obviously I was storing that in the second part of the pair. Okay. So it would be 20 plus 1. Third option, I am telling you the third option. I have already told you the option 1 and option 2 is 20 and 1. And option 3 I would have to make, which is 20 plus 1 plus 2. So it is 23. And you can see here, and you can see here, what you can see here, that now 2 will return 23 because it has make, and you can also observe that obviously the answer is 23. 20 plus 2 plus 1, it is 23. That's why I am telling you now that if at each node I can obtain this quantity. Okay, so this is the answer for this node 2. Similarly I will compute for the node 10 also. Let's first try run. And now I have told you that I will have also to return the second quantity, which is the maximum path maximum path in the left and the right. So what is this? It is 1 1 comma 20. Either I will do 1 plus 2, 1 plus 2, or 20 plus 2, and we'll take the maximum of both. So obviously the maximum is 22. So at node 2, I will return 23 comma 22. What does this indicating? Means the answer, the maximum answer at node 2 is possible is 23, and the maximum path sum including the root node and either of the right child or the left child path is 22. And obviously you can see it is 2 plus 20 is equals to 22. So I hope that you are clear with the differences between these two quantities. Okay. Now I am at node 10. I am at node 10. I will just call to the minus 25 because I am not having the answer from the right child. So I will call that. Similarly, it will call to 3 and it will call to 4. So again, it will receive 4 comma 4 and it will receive 3 comma 3 from the left and the right child correspondingly. Now I will again do the same what I have done here. Okay. I am having 3 comma 3 and second quantity is having is 4 comma 4. Okay. So again, to make the answer for the this node, I will again have this three options. Either to take the maximum of these means that to take the maximum of this which is option 2, this is option 1, and option 3 you I have already discussed what it would be. 3 plus 4, 3 plus 4 plus root data. So obviously you can see if I just include 3 plus 4 plus minus 25, so obviously it would become negative, and what it would be minus 25 plus 7, so it would be 18. Okay. So now minus 18, so at minus 25 it would return minus 18, and for the path sum, for the path sum either in the left path or in the right path, I will just do 4 plus minus 25, so it is minus 21, and plus 20 minus 25 plus 3, what it is minus 22. Since both of these are negative, so what I have told you, consider this step. If it is less than 0, I will return 0. It's better to return 0, so I will return 0 from here. So finally I am at node 10. Finally I am at node 10. Just remember what I have written. At node 2 I was having 23 comma 22, 23 comma 22, and from node 25 I am having minus 18, minus 18 comma 0, minus 18 comma 0. Okay. Now I have to make the answer at the node 10. So is first option is to take this one. Second option is to take this one, and the third option we have to make. How to make the third option? 10 plus 10 plus path sum in the path sum means what I am saying. What I mean by the path sum is to take this like this. Okay, we have to just go to the leaf node, means until we go get the positive answer. So now it would be 22 plus 0 plus 10, it would be 32. So now our answer would be 32. Okay. And for the second part, which is the path sum, we have to return 10 plus 20, uh, what I have forgot. Okay, 10 plus 22. So obviously our answer would be 32, maximum 32 comma 23 comma minus 18. So obviously our answer would be 32. We would just choose 32. So yeah, in this way I have make my answer. Thank you.